Hi kids, today I'll be talking about our last new topic called loops. A loop is when you want to repeat something. Now I can teach loops in a variety of ways, but the way I suggest is to identify the need for a loop when you have a number pattern. The pattern that I'm going to use is 25, 50, 75, my bad, 25, 75, 125, 175, 225, 275, 325, 375, 425, and finally 475. Now I would like you to think about a couple of things. What's the initial value? What's the change? And what's the final value? I'll give you a couple of seconds to think about these three things and then we'll fill them together. Alright, the initial value in this pattern is 25. What's the change from one value to the other? So from 25 to 75 is 50. From 75 to 125 is also 50. From 125 to 175 is also 50, and so on and so forth. So we know that the change is 50 and is consistent. Now that is important, that the change is consistent, that it's increasing by 50. So that I represent by saying plus 50 every time. What's the final value? And the final value, as we can see, is 475. Now, one way in which we can draw this pattern is, of course, we can say just print it, just print this whole pattern. But that would be cheating, because the pattern is not small. If the pattern is really, really long, you cannot do that. So that's out of the question. Another way in which I can do that is I can initialize it to 25, display the value of x, and then display a little space, and increase it by 50 every time, which is my change. And if I could go back to line 9. If I could, I would like to go back to line 9. As long as x is less than or equal to 45. But yeah, so I want to go back to line 9. So you'll see that the initialization happens once. But what we want to do, and the update happens over and over as long as x is less than or equal to 475. And that is what a while loop achieves. Just like an if condition, it has a header, it's while. So while, in round brackets, you have the expression or the condition, x is less than or equal to 475. I want to do these three things. So I put that in curly brackets. So the way a while loop works is, if this condition, this Boolean expression as we call it technically, if that is true, which it is because x is 25 initially, it goes to line 11, 12, 13, and then comes back to line number 10. So x is 25, yes, it's less than or equal to 475. It will display 25 and a space and increase it to 75. Then 75 is less than or equal to 475, yes. So it will display x, it will display a space, it will increase x to 125. It will then check, is it less than or equal to 475? Yes. So it will go to 175. Similarly, 225, 275, 325, 375, 425, 475. When x is at 475, it is still less than or equal to 475. So it will still display 475, display a space, increase x to 525, which is when x less than or equal to 475 is no longer true. Because that condition is no longer true, the loop body does not execute and it comes to line 16 and the program ends. Let's run this program and you can see I have my output in the console 25 through 475. If you change the less than equal to less than only, it will only go to 425 because when it is at 475, 475 is not less than 475. So that's how you identify the need for a loop and come up with the initial value, the final value, and the change. Now, how do we use it? So you can see that here I have a number pattern and I'm going to convert that into a nice graphical program. So instead of printing X, I'm going to draw a circle at X and Y is always height by 2 and diameter is always 50. I'll fill this with random shades of red, green, and blue, and no stroke. So now instead of displaying these numbers 25, 75, 125, we are using them as the center X coordinate where these circles will be drawn. So when I run this now, I've got these beautiful circles at X equals 25, 75, 125, 225, 275, and so on and so forth. So when you have a patterned graphic you would like to display, which is a regular pattern, you can use a loop. Let's take a second program. Again, I'm going to keep the size as 600, 600, and the background is this time 0, and the stroke is 240, 240, 80. I'll have X as 10 while X is less than width. Each time I'm going to draw a line from X, and now this is X and 0 to 0 comma height minus X. So trust me, and stroke weight is 3. And each time X increases by 10. I'm also going to draw a line from X0, or let's say width minus X0 to width height minus X. Yep, that would work. I'm also going to draw a line, same lines as the first one, except the Y coordinate is height, and this will be X. So this is off the top of my head, creating a little graphic, and when I run this, I get this beautiful fractal shape. Maybe the thickness of the fractals is a bit too much, or the distance is too much, so I can increase the distance, that's okay. And you can see this beautiful spider web. If I comment out 3 of the 4 lines, you can see that's the impact of the first line. So it's drawing a line from 10, 0 to 0, 490, 20, 0 to 0, 480, 30, 0 to 0, 470, 40, 0 to 0, 460, and so on and so forth. So it's drawing these lines that slant like that, and that's how I get my beautiful fractal. Using graphics, you can do a lot of things, just like this one. So in the take-home practice exercises, I'll give you some tasks, obviously not as complex as this one, but something that you can use loops to achieve. A bit like the first program, where you have these circles. So hope you enjoy them, and we'll spend the last 2 weeks just putting together whatever we have learned into one nice program. See you later.